Alrighty, so in the past, we've often looked for outliers. And the way we've looked for outliers is we've looked at the numbers and say the data set was like 2, 10, 12, 13, 14, 15, 29. Well, people would just be like, 2's an outlier and 29's an outlier. But that doesn't seem very mathematical. It's not very good to just have to look at the numbers and go, I think that number is too big, or I think that number is too small. We don't like that in general. It's not a very intelligent way of working, because it basically says, well, if I think that it is an outlier, then it is an outlier. And that's not really good maths. So we have a rule for working out whether something actually is an outlier. And it's to do with our interquartile range, and our quartiles. So what we say is that our lower bound, meaning anything below this would be considered an outlier, is calculated by taking Q1 and subtracting the interquartile range. But doing that's not good enough. We want it to be a little bit bigger. So we go 1.5 times the interquartile range. And for our upper bound, we basically do the same thing except for the quartile 3. So we take the third quartile and we add 1.5 times the interquartile range. Now, another way you might see this written, and in fact, this is the way it's written on the formula sheet for you guys, and this one is given to you on the formula sheet, is that Q1 minus 1.5 times IQR, that looks fine, is less than or equal to X, is less than or equal to Q3 plus 1.5 times IQR. Okay, so they write it all on one line. They don't tell you which is the upper bound and which is the lower bound. And it kind of makes sense because X just represents our numbers, and so we use this to determine whether a number is within the data set or outside. So if it's in between this lower bound and this upper bound, then we say that it's a normal data. If it's outside of that, then it is not. So why do we do this? Well, let's think it from a box and whiskers plot, okay? So let's imagine we've got our box plot that looks like this, right? You can see we've got our Q3 over here, our Q1 over here, and this is our interquartile range. What we're saying is that it's fine as long as you're this distance, this interquartile range, or this distance and a half away from it. So we're saying that the upper bound is this plus this distance, and then minus this distance as well. But a little bit longer, so the 1.5 just means it's slightly longer than that distance. And that then becomes our borders. So if anything is outside of that, we consider them an outlier. And when we do a box plot and we do have outliers, we draw them as dots, and they don't count as our minimums or our maximums. We just draw them as dots instead. And often it's the mins and the maxes that do get cut because they're either too big or too small. Alrighty, so let's actually go through an example calculation. So determine whether any of the values in the following data set would be regarded as outliers. Alrighty, well, what do we need? Well, we need our Q1 and our Q3 in our interquartile range. Well, in order to find any of that, we need our median first. Is the data in order? Yes, it is. So let's do our median first. How many data is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n equals 11, n plus 1 over 2. 11 plus 1 over 2 is 6th position. So 1, 2, 3, 4, 5, 6. So the 6th number is that. We now have our lower set and our upper set. So the median is 8. We actually don't need the median, but it's good to be consistent and get into the good habits. Q1 is going to be, well, there's only 5 numbers there, so n equals 5. 5 plus 1 over 2 is the 3rd position. So it's going to be a 7. Q3, well, n also equals 5, which means that 5 plus 1 over 2 is also going to be in the 3rd position. The 3rd position is a 13, so Q3 equals 13. And we now have all of the information that we need. So let's work out our interquartile range, and then we'll go forward. IQR equals Q3, take Q1. 13 minus 7 is 6. The lower bound, meaning any number smaller than this, is too small, and the lower bound is equal to Q1 minus 1.5 times IQR. And we know both Q1 and IQR. Q1 we worked out to be 7, 1.5 times 6. And this is equal to negative 0.5. My apologies, negative 2. So it means any numbers smaller than negative 2 are outliers. So what's our smallest number in our data set? Well, our smallest number in our data set is actually this one here. And this one is actually okay. Why? Because it is not smaller than negative 2. It's all good. It gets to stay. Let's check the upper bound now. So the upper bound is Q3 plus 1.5 times IQR. Q3 worked out to be 13. 1.5 times 6 is 9. 9 plus 13 is 22. Are there any numbers bigger than 22? Well, yes, there is. So the only outlier must not fit between negative 2 and 22. Well, looking at the data set, 23 is the only outlier, because it is bigger than 22. Alrighty. So that's how we work out outliers. Notice it's not just willy-nilly. You can't just look at a data set and go, I think one's too small. No, we have a calculation to check whether it is an outlier or not. Alrighty, see you in the next one. Goodbye.